Hello. So, yeah, don't totally know where to begin. Uh, a lot of things happened this week. Actually, particularly yesterday, which is kind of cool. Um, I'm just gonna go through a bit some of the stuff that I did. Um, I guess to provide some context. And then I can show some stuff off. Pretty sure I have Unity. No, Unity's closed. So I'll open that up. Um, yeah, but a lot of things happen, and often they're not always the interesting things too. For instance, I have record of me fixing basically three bugs in the code base this week. So like the super fun stuff, mostly serialization stuff, which is like how things get saved. Um, there's like a lot of metadata that gets recorded as things get deserialized because it's really useful to have like when you're trying to figure out what something is, and things get weird, it's useful to have points of reference. So anyway, Unity's loading right now, but some of those things are like where within the file did data get loaded? Um, so here, I'll actually show this because it's not going to make a whole lot of sense out of context if I just talk about it. Um, all right. So for instance, if we have like this, right? Like these are the extracted files, right? Like so if you're trying to figure out what stage files are, right? Here, well, these are all the decompressed files. Um, if we open this with a hex editor, right? Like often, I say often, when you begin reverse engineering, this is what you're looking at, probably for many days. And as you can probably tell, a lot of this stuff doesn't necessarily make a whole lot of sense. But if we look at like these, for instance, I know what this value is. So if I highlight these 4 bytes and I organize it um, as big endian, right? So there's different ways to order the bytes. If you do a big endian order on those 4 bytes, it's actually a float, which is say like a decimal point number, right? And so when you're in the middle of doing this and other stuff, it's really useful to know. Right? Like I also know for a fact that, no, I can make this easy. I know that this is a pointer. So if I were to, go to somewhere in the file, and then start looking at like, well, what is this data here? It would be really useful if in say your spreadsheet, when I export stuff, if I could actually know what that address is, right? So yeah, a lot of the unsexy stuff that you end up working on is fixing bugs where like, anyway, for this last week, the address values they weren't persistent, which means like after loading it in once, they would disappear. And same kind of bug was happening for if the file is AX or GX, so I couldn't tell that anymore in my spreadsheets and stuff like that. And then another sort of edge case with 2D arrays, which is like an array of an array. Anyway, so those are some of the things that I did this week. So those things take a bit of time, right? Some of them are usually quicker because I can kind of tell what that is. Also got a doggo sort of unhappy. Someone's probably delivering a package. Yeah, right. So anyway, those are kind of the things that take time that you kind of need to just do. So one thing I want to point out is like often, like every week, there's always stuff like that going on. Because that's just kind of the nature of development. But anyway, so some of the cool things from this week, and I'm gonna try and throw up images whenever I can and stuff like that. So this week sort of now that, yeah. Uh, this week, yeah, so sorry. Some of the stuff sort of been focusing on is what I've been calling the track transform. There's probably a better name for it. I'm going to change it eventually. But the idea is that, here, if I move my console window, right? So this is what green plant intersection. When you're looking at the data, right? Like again, so this is to go back way back to last year. Like I didn't need to go in and figure out how to import models and stuff into the project because somebody else figured it out, right? Part of the reason why last year that was the focus of being able to bring all this stuff in is it gives context to a lot of this track data, right? So you'll notice that there's like these floating cubes of various colors. And you'll kind of see them all through here. The game is keeping track of the track data using basically what's called like a transform hierarchy. So you'll see this a lot, right, in like 3D software where if I have a look, right, and I go here, it's kind of like if I zoom in on one, it's kind of like you have an object that has a position and a scale and a rotation, and then there's a child object underneath and so on. And as the scale and the rotation and the position change, for every child, it's like relative to its parent. And that is kind of the structure of like what I'm assuming is a control point for the track data. And because of that, it's really hard, as you might imagine, right? Like if I were to remove, all of these models, if I just turned all this stuff off, as you might imagine, this might be a little bit difficult to parse, right? Like, no, of course, I don't have it on screen. Right? Like trying to figure out what this is supposed to mean would be pretty difficult, right? And that's part of the reason why having all this data in is really crucial, because then you can sort of understand what the track is in context, right? Like understanding what that stuff is. So yeah, so that's been like the theme of the week, is trying to figure out what all these like different control points kind of mean. You know what? I can do this in a way where I don't have to keep moving this stuff around. Yeah, I'll just squish things over a bit. Put that one in there. So that's been the theme of the week, is the stuff. And so a lot of it's been, poking at these different scenes and kind of figuring out, trying to figure out what this stuff actually is. And really everything that you're seeing in, like in here, every piece of data from every track is in this one spreadsheet. So this is GX exclusively, and you'll see that there are 3,191, because the first row is the header. There's that many pieces of data. And it's a lot, right? But what's nice about that is you can start sort of figuring out what all the weird edge cases are. So for instance, I'm just going to show like these, these 12 nodes here. This is the first course. And what exactly those points are showing is all of these. Right, so all of these control points, there's about a dozen, like 0 to 11. And so over the course of the week, we've been able to figure out a couple things. One is it is sort of definitely a transform hierarchy, right? So on the right here, this is what that data kind of looks like what's actually in any one of those control points for a course. And that's in part why it's been really hard to piece together. There's a lot of like very specific data that, it takes a while to figure out what it's supposed to be. And then again, a bunch of curve data, but then you also have these transforms, right? Which is sort of where things are and how it's scaled, and it does stuff super weird. And so, yeah, part of it's been figuring out and dissecting what all these things are. And so we've been able, figuring out a bunch of this stuff, and I think this might be a case where it might be worth opening the code. Yeah, so there are definitely some kind of transform matrix. And really what that means is Portown Erodive? No. 9. 7. Yeah. If I were to go and say, actually, let's see, display track transform. Oof. Okay, there we go. If I select all of these and I do this, you'll see that there's a lot of stuff going on here. This is a way of kind of showing off what all that track data is, and it's not great. Right? This is actually what that would look like, I think. Or actually, what I need to do, I changed something, so negative -1. Yeah. So like, again, it kind of shows, right? Like you can figure out that like for some of this stuff, right? Like it is the width of the track and stuff like that. And part of it is through this crazy transform hierarchy that it has. We'll figure out how to like position things sometimes, right? Position things like appropriately. And then other times, not so much. And so that's kind of part of the challenge here, is figuring out all these different things. And so anyway, in the code, a lot of those things are being figured out. So more or less, this is what I've been staring at for the last week. Right, so we got like our transform values, we got some pointers. The interesting thing for today is probably going to be talking about these different things here. And then there's some data I'm trying to figure out, and basically some things figured out from last week are constants, except for those last ones. Still got to figure that out. But I got to do a couple things. One thing this week that I had to wrap my head around, that's useful, is, again, so matrices, it's vector math, which is to say, like, how do you represent position, rotation, and scale? What does that data look like? And, what parts are scale, what parts are rotation, what parts are position? And then basically the thing that came out of this week was we kind of knew how to do this, but I had to learn to go and basically transpose the matrix, because the game stores it as rows and Unity loads it as columns, so I had to do some weird stuff. But anyway, that was fun, let's say. But once I had a look and it was pretty clear that it was going to be some kind of transform hierarchy. Then it was a matter of figuring out, like at the time, all of this stuff here was just gibberish, right? Like we didn't actually know what any of that stuff meant. And so it was a matter of figuring that out. So what I've realized is there's a couple different things. One is that for each, I guess you could call it like a node type, for each control point in that hierarchy, there's sort of like a flag defining what it is. There's a one saying like, hey, if it's using another value, it gets tagged as something. If that part of the track is either a pipe or a cylinder, and this is kind of interesting. The game doesn't care too much if something is a pipe or a cylinder, and so the distinction here, for at least for me, a pipe is something that, you know, like a tube, right? Something that you go in, that's a circle. And a cylinder is a thing that you drive on, that is a circle. The game kind of doesn't care which of the two it is. It kind of just says like, hey, that is a thing, and then somewhere else in the data defines if you're using the inside or the outside of the circle as the drivable surface, which is kind of interesting and not what I expected. You have a flag to say if something is at the top of the hierarchy, and you have, or I guess this case would be the bottom. You also have one to indicate if you're at the top of the hierarchy or not the final node, really. And there's also a flag to indicate if something is a branch, which is pretty interesting. So obviously you have things like mute city serial gaps, right? Like there's a branch, there's two different paths you can take. There's also, you know, Cosmo Terminal, Trident, right? But this is also used for when you have like two hill strips or two dirt pits or two, you know, if you have ice on either side of the track. It actually creates a branch node for that data, which is pretty interesting. And so I guess to illustrate that, I'll go to, I spent a lot of time on this track recently. And so if I go and look at, say, some of the ice here, right? So we got this. I'm going to go and visualize this a bit more. Right, so if we did this, right? So, right, this is ice for Mid City. And I believe this is 26. Is it 26? And we can figure out. Is dirt? No. So this is, I've gone too far. Yeah, right. So we have this flag is ice. And so this, like this one little node here, which is really interesting, this one branches off into two, right? So this one says, or I suppose these two say, huh. That is interesting. That is something I need to note down. Is branch. All right. So still figuring stuff out. But what's interesting, right? So if I go and look at this, this might not look like a whole lot right now. But if I kind of widen this out, and perhaps a little bit more, right? This path here is actually like this shape over here, right? So you can think of this as like the width. So the way it works is over time. So this is like 0, this is wherever the end is. And so the width changes from basically 0.4 over here. So 0.4 goes to like 0.4 and something, and then it goes to almost 0.5, again, almost 0.5, and then goes back down a bit, and then goes back up just a tiny bit, right? So properties like that are in fact in the data, which is kind of interesting. And there's usually kind of like a mirror image. And my suspicion is that this is scale, that's rotation, this is position. So it might have something to do with that. It might actually just be the other side as well. Kind of hard to tell sometimes. Right, because we kind of have, again, the left and the right. So some kind of property there. And the reason this is of note is it's kind of strange for this stuff to be in the file, right? Like, again, all of, like this, I mean, this is like the visual mesh of, the ice, but that same mesh is stored as collision. And so the fact that that data is still stored in the track either means that there is a use case for it, or they're just saving. It might just be easier for them to just be like saving all of that data that's part of, again, like whatever they had in mind, just like saving it out. But anyway, so it's sort of interesting that that's a thing. Yeah, and again, so then like branching paths, you'll have like these, because normally it's you can think of it almost like a ladder. It always just goes down one, unless you hit something where there's like 2 or 3 halves or something. Because then you're defining each curve like as its own thing. Right, so that's part of what was figured out. Right, so like this is kind of nice, right? So we know that it stores lava because stage or story 7. Interestingly, story 7 is the only one that stores lava. I think the only other level that has that is story 8. And as I was mentioning the other time, story 8 is like old, so it's not actually storing that data, it seems like, anyway. The heel pit is also interesting, right? Because this explains things like Lightning Thunder Road, right? Where if you recall the last curve for like the heel strip, that's there. Yeah, Panzer, hey, nice to see you. It's been forever. Yeah, so again, based on what I understand, right? Like there's this weird hierarchy thing going on, but right, like in something like Maya, my understanding is right, like you kind of have that, or it's not Maya. In 3ds Max, you have like a modifier stack, and right, like every time you add something to your mesh, it's like a modification layer, right? This kind of feels like something like that, where right, like you're attaching, right, like they're defining some kind of spline for the track, and it's using width and all these other things, right? And then on top of that, then you add like the next layer, and eventually, usually towards the bottom, the last node that you get. So for instance, on this node, like if I walk down, it doesn't really matter where it is, but if I walk down this, you'll notice that there's like this perimeter option. And as I go down, only once I hit the last node does it say has rail height right. And you can also have a rail height left. And then that gets defined over here, right? So the rail height right is 6 units tall and the rail height left is 0 units. And so, right, like, so there's some kind of modification stack going on where like this is a root node, and what's kind of interesting, I have those colored red. Like sometimes it really doesn't matter where they are, like seemingly anyway, because you got some of these like that are over there and that's connected to this node over here for whatever reason. And other times it makes way more sense where we have a red node here. I could adjust the size, but it's going to take a bit of time. You have the root node here, and then it goes to this node. And then there's some kind of definition that's sort of saying from here, to the next point, like rotate 90 degrees, right? And you can kind of see where that arc is going. So if I do this, and then ISO, right? So from here to here, rotate 90 degrees, and then from the center point to here, it's going to rotate 180. And then presumably from here to somewhere, there's other stuff. But like sometimes the hierarchy seems to escape me or fail me, because you'll notice that there's this like a really weird little node sitting at the front. And it's just kind of, here, I'll do perspective. And it kind of just goes off wherever it wants. Like it's kind of rotated really stupid. As you can see, it's like off tilt and pointing out, when it kind of seems to make sense that it would actually point to this end, like not rotated. So still not totally sure why that is or what exactly. But you know, like there's like evidence of things somewhat making sense. Like I think if I go down to this ISO view and kind of clip in a bit, right? Like from is it this one? I forget. But there was some data around here that kind of, all right, it was this one. So if I go from top down, it's hard to see, right? Because it's tiny, so it's this little guy. From this point to these points, so it goes from the red to the yellow. So there's a yellow here, and then from yellow to green, and then it rotates 90 degrees up to this. Actually, I'll take out the image that I made, which shows this off better. Right, so basically what you're getting is this, where from this point down to yellow, like that's the first part, and then green is a child of yellow, which is there. And then if you sweep it 90 degrees around this pivot point, right, from this yellow to this yellow, and from that green to that green, that actually puts your center line as well as like the half width of the pipe, right? Because all the pipe really is like this half width from a center point to the side, and then you copy that width to the other side, and then you just have radius of the track around, you know, that kind of center point. Right, so like the stuff is in there. It's just kind of hard to figure out how the hierarchy works in some of that other stuff. And like if I go to here, right, so if I go to this stage, right, if I look at the curve, right, so this one's kind of nice. There's only a couple curves, right? Again, it's like weird that there's this much stuff, but anyway, if I look at the first control point, if I look at the x of the first one, which we know is to be like scale, the curve goes from 60, right? It's 10 above 50, up to 160. And that's the width, right? The width at this point from here is, right, like it's for that much time, whatever that is, that's your 60, and then it widens to be up to 160 units. And I, in fact, built a little, if I can locate it. I guess it doesn't matter too much. Can't find it. I'll open it on Discord. I made like a little ruler tool, and just to figure out if those things line up, right? And like it does. So, right, like this is the really weird thing that's going on, is we know that there's curve data and that the curve data relates to the track, and we know we have these transform values, and the transform values relate to like the control points, but it's kind of hard to figure out exactly where those control points are supposed to be. I mean, so because like sometimes for this course, all of the control points technically, their position, or at least their root position, is all 0, 0, 0. Like that's it. The most complex thing that we have is right, like these 2 points here, which again are at like 0, 0. We know that these are the heel pit parameters now. Which is like, okay, it's cool that we know that, but why are the control points for this entire stage just here with some curve data, when for other stages like stage 3, why is it like this giant, this giant hierarchy with a million things in it? So anyway, hard to pin down a lot of those things, especially when some of them start looking wrong. Or like offset, like these ones are really strange, like these blue ones, because they're kind of off in the middle of nowhere, but if you line them up right, like if you have the ISO view, these are actually like the center points of those other 2 track pieces, but they're currently not very connected. And so it's like, is it in the curve data that those things are offset? Is it elsewhere? Who knows? But anyway, so that's kind of right. That's kind of a lot of what's going on, right? So we kind of have these things going on. So anyway, all right, and like this is just one part of the definition. And I guess one thing to mention too is within all of this curve data, we also have like if a track is modified using that stuff. And so one track that's really interesting in that regard is Firefield Undulation. If I can, here, let's just open them all up. I think it was around 9. Yeah. So if we go to this control point, which again is kind of okay, right? So it's by all of those like wavy undulations. Right? What's nice is like, hey, there it is. If we again we zoom out a bit and make it wide. Oh boy. Shouldn't have done that. Wasn't focused in on the right part. Right? So, right, like this wavy here, right, is the same wavy as the track. But this is along, right, like this is along the x-axis. And then if we go up one control point, what's interesting is we now have this like crazy kind of sine wave. And if I zoom out just a little bit, right, like this is basically, right, so we have the previous node, the bottom node, that defines the width, right? And then you go up a node and then you have the height, right? So basically this is a modulation on the subsequent modulation, right? So this is, like the fact that this gradient, here, let's get rid of this stuff so we can actually have a look. And we don't even need that, right? So if you kind of look at the shape, right, it kind of fluctuates like in and out, right? Or I guess there's like right, like there's a positive and negative y value being added to the height. And, right, like that's kind of what we're getting. Shoot, lost it. Yeah, right, so then, right, like this is the height across this piece. Oh my god, I'm so far out. Right, so this is the height across the whole piece here, and then you have like the cross section, if you will. Or so that at least seems to be the case, right? So it's interesting and strange, right? And then before here, like once we get to this point, we also have, oh, that's kind of not quite it, right? But we have different things going on, all right, for like all of this data. So, right? So it's, anyway, it's nice to know that like this curve data, like this stuff, is actually just a property. And if we go to the bottom, you have this like is modulated option. So you can define if something is a capsule pipe. Again, so that's something that's interesting, is there's an explicit flag for if it's a capsule pipe, if it's a pipe or a cylinder, or if it's modulated, which is to say, right, like if there's something going on with the cross section. Because if we go to lightning, everyone's favorite, and we go to one of the control points, let's open these up again. If we go to a control point sort of near the end, interesting. Right, like if we go, right, like again, right, so you'll notice that, hey, this kind of looks like, right, the dent in the track on lightning. And what's nice about that is, in fact, that is what it is, right? So we know that this track is modulated. This is the modulation graph. So it's like, okay, right? At least we know where the stuff is. And again, a lot of the stuff is like on the last node. It tells us, oftentimes anyway, it tells us what the track is supposed to be. Unless it's not a track, right? Unless it's like a different parameter. And then it also, again, tells us if it has a rail height and if it has a rail, again, rail height on either side. So anyway, right, that's part of this week, was figuring out this stuff as it relates to the track. So many things. And then there's also, right, so then there's those track properties. So what's kind of going on for that given piece. Right, there's these perimeter options. So the game keeps track of, which side has rails, which explains the really high rails on Portan Aerodive, right? But it also keeps track if the corner that you're going into, or if that, right? So we have this hierarchy, and within the hierarchy, there's an optional parameter for if there was a corner, specifically if it's like a 90-degree turn left or right. Right, so if you think of Lightning Thunder Road, like the AX Cup one, or some of the turns near the ice on Mute City Serial Gaps, or Aeropolis Multiplex, right? You get those, like some of those sharp corners. That is actually like additional information that gets embedded. So there's flags for, I guess, I call it perimeter options because you're kind of going around a perimeter anyway of some sort. So that gets tagged, and when that exists, you get this thing, which, this is kind of what I thought it was earlier. Figure out that's like a matrix. There's some kind of rotation value, I think, anyway, because it's minus 90 to 180, which usually means rotation. What's nice is there's a bunch of constants. And then there's also perimeter options. So basically, if the last node defines saying like, hey, that this is in fact a corner, then it jumps into this node, which has some options, and then this defines if that corner has walls on the left and right, which is interesting. Alice. Well, once that's done, then hey, I'm sure I'll still be around, and there's going to be lots of stuff to do. So, um, but yeah. So anyway, so it's interesting that the game stores this as like a separate value. It makes sense though, right? Like if we go and grab a yeah. So most of the time, it's a good question, right? Like rotations in degrees and not radians. Yeah, so in games, unless you're like optimizing a math library or something, you're probably going to use degrees. Probably mostly for the fact that that is the values that humans read. Right? So like if you have someone that's again, like you have to understand too, like the background of some people. If you have a background in animation, like you're probably not thinking in radians, right? Like you're thinking in degrees. And it also has to do with like animation data, right? Like when you look at any specific node here, right? Like if you're gonna modulate rotation, you're not gonna say like, well, I want to go between, quarter pi and tau. Like no one's gonna be doing that in their head. And no one's gonna be punching in, like what the heck is a third of a radian? Right? Like, or what is the third of pi for me to stick in for the rotation for this piece of stuff? Right? So everything's usually degrees, and even the tangents. Like if right now I don't really have the tangents, but for tangents, even within like the editor and stuff, that's being stored as degrees, which personally I enjoy that. But for instance, if we look at like the transform, right? So there's a transform matrix. Technically, it's a 4x4 matrix, but it's only storing the matrix as 3x4 because the last row or the last column, right? However you want to. I guess no, it's the different ways of doing it. But for this instance, the last row is always 0, 0, 0, 1. So there's no reason to store 16 bytes, right? So it omits that stuff. So in this case, this really is a rotation matrix. But for like some of the last rotation thing, I had to figure out how to decompose a rotation. That technically stores radians as a fixed point value between -1 and 1. But yeah, so in a sense, that's going on for some stuff, and for other things it doesn't. So anything that's like, I guess like on the authoring side, like for where humans have to input data, yeah, it's gonna be in degrees. But yeah, so that's it's kind of neat. So if I go to, let's go to, oh, not 5, just too many buildings always have to turn off. Right, so if we go to this lowly stage, right, you got all these like 90-degree corners, right? And technically, like you could define this as like a spline kind of going through the section, and then you constantly modify like the width and the angle. But it kind of just makes more sense to do it that way, because otherwise you're kind of like bunching up, like railing, like it would all sort of be in one spot. And then you got weird stuff going on for like, well, if the rail is continuous at the corner, right, because you're doing weird stuff, then like, can you hit it forward, or is there going to be some weird math going on when that happens, right? So anyway, anytime you have like this, this is kind of its own custom data. And there's basically 2 different versions of that. The other version, oh boy. Come on. Okay. The other version is these these like 90, these kind of 90-degree curves here, but that are rounded. These also qualify as 90-degree turns, and there's like specific parameters. I say specific parameters. The data, right? It's still a 90-degree turn, but it's done differently. Rather than like 2 nodes, there's usually 3. Right, so anytime you get, right, so again, you got a lot of these going on story story 3, right? You got these 90-degree turns that are hard cornered, and then you have these like soft cornered ones. Right, so that's sort of its own data, right? So probably this one, it's like this. And then if I look at if it's got a corner, I guess that's not the one. This is the one before. Or is it the one after? Maybe it's the one after. Well, I'll find it at some point, but that's the idea. Yeah, so Hollis, that's a good question. I don't know yet. I guess what I will do is let me go ahead and show you what that looks like. Again, this spreadsheet, this is like the best thing to do. Right, so if I wanted, once I have this set up as a table, right, I can just do stuff like, I only want to know about things that have 90-degree turns, right, and then these two. So let's do some math here. We have a total of 64 pieces of data that identify themselves as being part of a 90-degree corner. And when that happens, well, there's a transform which I'm emitting from the spreadsheet, but then these are the values, right? So some kind of rotation value that's in there. And then some values. So if we have a look at, say, let's see, we've got stage 3, 5, 7, or 27. Yeah, so this is all of our story 3. And oh, I don't have it in here. Well, here, let's do that. Story 3, second node. Okay, I'll have this on the side. So part of what I can do here is I can identify which node is which. And right, so we have like these perimeters and all this stuff. And if we go and check out where this one's at, kind of looks like it's in the middle of nowhere. Okay, so it's probably defining part of this here. Then there's kind of like usually a node that's like at the halfway mark, sort of between this stuff. And so on and so forth. So I had it. I wonder. I was exporting like a different kind of sheet before. It might just be the hierarchy depth. Let's see. Got 3 things here. If we keep going along the track. Yeah, so this one. Yeah. So like the ones that are curved tend to go in like 1 deeper, right? So like there's a third child rather than just 2. And that seems to relate to how that curve gets defined. Because if you think about it, the only difference between those two is one, right? Like one just has a hard corner, while as the other one is curved, right? So then we got, right? Like, so if we look at this, right? So we got this animation data. So that one's linear, but this one, right? Like this basically defines your curve for the corner. You just kind of have to think about it in a different way. Like that's what defines that outside edge. So technically there are, not that there are end sides, it's that it's a continuous value, right? Just like the corner of a circle. When it gets converted into a mesh, right? Like that's when you get quote unquote end sides. But it looks like essentially that those edges of those turns, you can like define in some way using those parameters. So you could probably do some crazy stuff where like it actually like it widens or it bubbles around the corner, or it's like a diagonal cut. You could probably figure out some way to do that too. So there's some stuff in there. I'm not totally sure what yet, but again, that kind of it's its own kind of like little data set. On one of these points anyway. But yeah, so there's some kind of rotation thing going on. That might be for the height here. Anyway, the whole thing. So let's see. Yeah. So that's that. Right, that's the corner. There's some options. Yeah, and then there's this other parameter, right? So, right, I was talking about before how there's this like metadata, right? Which says if you're a pipe or a cylinder. What's interesting is that that gets paired with this, which defines how that pipe or cylinder works. So there's one flag that says, I just called it is the outer pipe or cylinder, which probably could rename that. But the idea being that there's a flag saying maybe I should just make these values or something. It's weird. So basically there's a Boolean that you toggle on or off to say if you're on the outside or the inside of like a pipe, right? So like if you want a cylinder, if you want a circle geometry that you're right on the outside of, this value is true, or the value is 1, however you want to think about it. And then if you want to write on the inside of the pipe, then this value is false. It's off. And that's how the game kind of figures out which side it's supposed to like put you on, which is kind of interesting. But then the other parameter too that's really important is open pipe or cylinder, right? So you know how there's parts of the track where like the cylinder goes from like a flat track and then it starts curving into a sphere. I say a sphere. It starts curving into a circle, right? So if you think like Portown long pipe, right? Like that's one of the first things that happens. Like the pipe goes from flat and sort of envelops in a circle around the track, right? That part of the track is tagged as being a pipe, but it's also tagged as it is an open pipe, right? So there's probably some curve data in there defining like how curved the pipe is, essentially, like how complete it is at being a circle, which is interesting. So, and this works for either pipe or cylinder, right? So for pipes, right? So you have Portown long pipe, but for cylinders, there's I think only one instance, and that's on Firefield cylinder knot, right? Lightning half pipe. Yes, and so all of lightning half pipe is an open pipe, essentially. And Firefield undulation, the half cylinder, is a cylinder. So I guess I just lied. I mean, Firefield has all of the half cylinders, but yeah, so there's the half cylinder for Firefield undulation, right? Like after the jump. and fire field cylinder not at the beginning. Technically, it's open until it closes, but they also put that like cube collision thing around the that end to kind of prevent you from using it, I guess. Yeah, so it's this parameter here. Yeah. And again, all of this stuff that has been figured out is just because I have a spreadsheet. Because I can sort of correlate like where are those happening, on what stages, and then what node, and then I can go look at that stage at that node, kind of figure out like what part of the track that kind of is, and stuff. Right, so like two of the parameters here, I got a filter on. For all of these parameters here, like this metadata, I don't really like is final topology node and is not final topology node. There's probably a deeper meaning there, but they're somewhat related. Yeah, I'd have to go and figure out exactly where in the collision table that stuff is. It's kind of on my to-do list of just right, because one of the things that's kind of nice once this stuff is set up, right, like somewhere in my code I have a function that can basically, based off some mesh data, generate a mesh in Unity. And so I can do the same thing with the collision. I can actually just generate mesh, and then store it to the database and then start pulling it in. And once I do that, that'll be interesting. Because like one of the things that I know happens is I think because like the more I look at this, the more I think it's weird. Like look at how this is like wide, this side is wider and this side is shorter, and so you kind of get like an ellipse, right? I think the game actually maybe, I could be wrong, I haven't seen the data in a while, but it might not actually be able to generate that collision property properly, because I remember seeing the collision for those rails around the corners stored in that tree, or rather in that table. So anyway, there's some weird stuff going on, but also there's like 15 or 16 different kinds of collision. I forget. But yeah, there's like so many different kinds of ways to void out, like instant death, losing control, yeah, stuff like that. I know if you've played F-Zero AX and you go and play Sand Ocean Lateral Shift, that's probably the easiest one to do it on, and you fall off the track and you hit the sand, in GX it kills you instantly, but in AX it actually you die because you hit it, but you like bounce off of it, which is pretty cool. Where it's kind of like, no, you just hit the ground and you lose your energy, and it considers you like off course and stuff. Right, so there's all these different things. So once I kind of get that in, and especially because now I have like all where all the objects are, I can actually start attaching collision for specific objects onto them. So like most I don't know, it's weird to say. It's like there's some of the collision, and here's the thing. Some of the collision is static, which is to say like it exists at a fixed point in the level and that's it. But there's also collision that gets tagged onto objects where it's like, you could say, well, like for this, well, that's not an individual thing. Here, let's go to the first course, because this happens here, right? Like, so you have the jump, right? You have the jump here. And this object is tagged with a ref mesh, so that if you drive off, here and you hit this, you're not just passing through it. But because that collision is used on this object, and I think possibly some other ones, that collision mesh gets stored in like a different part of the table. And then the object in the scene actually references that mesh, and so that mesh then gets, like, the transform of this object gets applied to the mesh and then sort of sits over top of it. So it's kind of interesting because you'll have things like a boost, like every boost pad on the stage, like that collision exists in like the collision table. Like it's static to the world, it never moves. It's kind of just is where it is. Right. So like if you change the level and didn't update the table, those parts in space would still be boost pads and heel strips and whatever. But if you actually moved this around and then saved the level and exported it back out properly, the collision would have moved with it, right? So there's like different ways that works, which makes sense. Like that's just kind of how most game engines work nowadays, unless you have a static object, in which case it can do pooling and other stuff. But yeah, so that's kind of what like these things are. The next real challenge is figuring out what the heck these things are and what this is. Because this is used a lot more, and there's a lot more values. Like these are flags, so there's many different combinations, which makes things harder. And that's kind of the case for all of these. But the only hunch I have for this one is once, or like you have track parameters, you have things related to the track, you have other nodes, and then you have the transform. So my only suspicion might be that these things could be related, where these flags could relate to the railing, possibly, in some way. Or it could relate to this one thing at the end here too, I don't know. It's also kind of interesting to note there's two values that are never used, but these two could actually be floats. It could actually be something else to do with railing. So it'll be interesting to... For this, it's really more like if someone goes and reverse engineers the code, knowing what most of this stuff does, they can have a look at if the code is even trying to use this stuff or not. But most likely, because there's a value after it, so something is here. Something that is normally 0 is here. But yeah, so that's kind of... Anyway, right, like, I don't know. I can't really estimate how much time I've ever spent working on this stuff. Like, I remember, like, these things. Let me go. Like this, like these control points. I've known about them and visualized them as a hierarchy since, like, 2016 or 2017. So I've known them for a while. It's just it's really weird. It does some really weird stuff, and it doesn't always make sense. So yeah. Yeah, and definitely if you have an AX machine within some kind of distance that you can do, definitely go do that. I did that in 2014, and that machine does not exist in that location anymore. So I don't think there's even any in Canada at this point. Not on the spreadsheet anyway. So yeah, definitely if you can, go do that. But yeah, so it's nice that we have those railings are messed up. Yeah, if it feels wonk again, right? Like that's partly the reason. Again, at one point I'll be able to visualize that, but I think that kind of corner collision is used multiple times, so it's stored once and then it's per object, which is kind of strange, but I think that's how that was working. But yeah, a lot of the additional collision mesh stuff that like doesn't need, I guess, how do I frame it? Okay, you're making this game, right? You're gonna be playing on the actual like track data, right? You're gonna be playing on that like 99.999% of the time. And so for everything else, like any drivable surface or collision or whatever, like you're hardly going to interact with it. And usually when you do, you don't do so intentionally. Like around those corners, right? If we go to stage 39, right? Like most of the time when you're going around this corner, you're not trying to hit the wall, right? So it doesn't make a whole lot of sense to put in additional effort to make those things feel really good, because as a player, you're not even trying to hit that. It's really just there to make sure that things don't blow up. It kind of just sucks when a drivable surface is the end of chapter 5. That's a bit of a different story, but right, like in 99.9% of cases, you don't really need that. So, but yeah. Anyway, there's a bunch of that stuff, and I'll be looking to it in the not so distant future. I'm probably gonna go and look at other stuff and then come back to this because, I mean, this did take me a good many hours, so I'm not gonna do something even harder than that right off the bat. My hope is that once I start figuring out some of these things, then it puts these in context, because that's kind of what happened here. Was like you do one and then you kind of notice a pattern, and then it's kind of related here, and then it kind of shows a pattern and it's kind of related there, right? So I'm hoping that that kind of happens for this stuff. But more or less, like all of this me just talking about stuff, this is more or less just one, like let me show. I mean, not all things are made even, but what I've been showing off, right, is if I go into GameCube, GameCube F-Zero, Course Collision, right? Like all of these classes, this is just for the single course file. Like just the course file has like all of these things in it and more, because I haven't figured everything out yet. And this is the one thing I was really looking at today, right? Some of these other things are like, like track property, like Bethanenum, so it's small, but that's just that. So one of the things I haven't even really talked about is topology. So basically, there's this one data type that's just a big 2D array of all the animation data. And so I have, some functions to kind of parse this stuff out. But like one of the bugs I had to fix this week was, like when you look at the animation data, if we go grab any of these, right? So if we look at this, right, like you have an animation key here, you have an animation key here, great. Left to right is time. You can never have two keys at the same time because it's like a linear, like left to right kind of thing. So if you have two keys over top of each other, well, really you just have one key and use the ladder key. But somehow in F-Zero GX's data, two of the keys have the same time. So I actually had to, I had to go and make this check that checks if you have two of the same keys, and then if it does have two of the same keys, I actually have to remove it from the index, generate a new array, and then return that, and then do that to make sure that that doesn't happen. Because basically I was getting null reference exceptions. Only for course 43. So story 7, for some reason, some part of the data, two keys, same time. And it was really screwing up. Because Unity was smart, and it removed a key, and then I had a index out of range exception. So I just read your comment, maybe for branching. Which specific set of data was I just talking about? I forget. But so branching is somewhat figured out. Like here, I guess I haven't really showed that. I haven't really looked at it too much, but I kind of know where it is. So if we go to course 24, cool. I know my stage numbers. So if I go to the control points, and I go to, even the first one, you'll see that like there's one control point and then immediately we have 3 after, right? So each one of these is one of those branches. Oh, I turned it around the wrong way. Right, so each one of these is its own control point, but beneath a main control point, we have these 3 control points and they each kind of have, so this is probably left to right. So this is probably the third branch is probably the left branch. The second branch is probably the right branch, or vice versa. And the middle one keeps going forward straight. Yeah. So I had a further look at that weird animation key thing. Basically, the previous 2 keys were kind of doing the same thing. There was like a time with a specific delta. And then the values, I forget what the value delta was, but it was kind of one thing. And then the next 2 keys had the same value delta, but the same time. And so my thought is that someone was probably doing that, and then they adjusted it by kind of like moving one key back to that first key, and then forgot about it or something. Or actually, not even forgot about it. They moved it back. The data made sense. It exported correctly. And their engine could handle it properly. However that's working, it was working. So, but if anything messes up for stage 43, there's that to look into. But yeah, so control points for multipath things kind of works like that. There's just like a main one, and then there's 3, and then it keeps going. So then, this point probably has, I don't know, got stuff going on. Right. Thingies. So, but yeah, so all of the branching and stuff, I say all of the branching, probably most of the branching. Again, it's just kind of this weird hierarchy with some animation data. But yeah, so it works on this here. So this is an animation curve in Unity, which gives you an animation graph. So a lot of it is converting the GX format into this one, which isn't hard. Their animation keys are sort of stored the same way. But I have to take it one from and put it in the other, and then I had to fix. If it weren't for stage 43 and that one error, my job would have taken like 2 hours less. And then let's see. Yeah, and then I guess other than that, yeah, I kind of went over most everything I did this week. The only other thing that I did was when generating, here, I guess I'll just show. The way it kind of works, right, is I can go and like import all of the stages. And so nothing's really changed for this, but like this is kind of what I have to do, right? So I have an object, it's set to load from a specific part of my computer, and it dumps it to this relative path in the project. And this is the search pattern quality course. 2 question marks says like any digit or any character kind of there. And then when I go to import, I'll just do the first stage. When I go to import, oh, this is stage 5. It does stuff like it figures out how many objects are in the scene to like kind of tag the number of objects for me automatically. And I have some stuff too, like right now I'm disabling all the objects that don't have a mesh. In the future, I wouldn't actually do this. I also tag it as like no mesh tag. So if I wanna find stuff, I can do no mesh tag. I can figure out everything in this scene that has no mesh. And then in the future, like there are some objects that actually are supposed to be disabled. Let me go out of ISO. Right, like if we go, this is stage 5. As you might notice, it's not very normal for the game to be putting a building that doesn't go all the way down through the track, right? So some of these objects are supposed to be disabled. Because like if you go into the stage viewer in GX, it actually loads all the objects, and if they're disabled, it doesn't care. It keeps them on. So you do actually have to go around this stage with like this crap in the way, basically. But I have to figure out where in the data that like disable flag is, so that we can properly like import the stages with any objects that are disabled, make them disabled, so that we can kind of do things more properly. Because there's going to be a point where, right, there's like just these buildings in the way, stuff like that. But yeah. And so a bunch of things on the to-do list. What's kind of interesting is an isometric view. It's actually pretty interesting how the buildings are laid out. Right, like, but for instance, it's like, we know that we can see this computer, so these buildings are probably disabled. Again, there's, these structures right in the middle that are also probably disabled. We have some overlapping objects, right? Like one of those sets is going to be turned off. So I'm going to be happy when I find where that data is. But yeah, it's a lot of stuff. Yeah. Anyway, that's that. So some of the other like maintenance stuff from this week is really just generating the scene better, and kind of making that stuff more modular, which is really useful. So I can start generating like triggers and other metadata and kind of putting them and stuffing them in different objects, right? Like these are all those triggers. Let's just do, right? So these are all the triggers from some of the other stuff that I was looking at. So we can start looking at those. And again, so there's just this guy that like doing his own thing. Not sure what this one's for. But yeah, just not even on the track. Yeah. So anyway, probably what I'm looking forward to next week, visualizing checkpoints smarter. So for instance, right, we got like these checkpoint. Oh my God. Yeah, every time I get here, I gotta like turn all this stuff off. These like 18,000 objects. Right, so again, there's some weird stuff with the visualizer for track transform. I'm probably gonna give that a break for a bit. And then for all these checkpoints, I'm probably gonna start, that's actually interesting. I'm probably gonna start visualizing them differently, because I can visualize their direction, I can visualize their width, right? So if I start visualizing those things, might better help understand how those track transforms work, right? Because there's, oh, right, can't do that in ISO. Right, because there's some very clear stuff, like, again, right, like here to here, you can kind of see that there's like, different intervals for that and how that works from like here to here and so on. So anyway, that'll be fun. So checkpoint, viz, and partly collision, or like importing that mesh table, possibly the object collision as well, and tacking it on. Because then with those things, again, I can get a better sense of what is where, and then sometimes that kind of visualization just helps figure out like some of the other stuff. Yeah. So anyway, that's kind of that. If anyone has questions, that would be a good time. Otherwise, I'm probably gonna let this be. But yeah, again, so lots of progress. Anytime figuring out like enums or like magic values, if you will, it's always a great great thing. And it also helps too, right? Like the more that gets figured out on this side, the more it's like, hey, if someone does look into the code, having that context is really helpful and stuff like that. So, but yeah, let's go on. Alrighty. Yeah, so well, that's a good point. I think that's to really know what's going on, I think we'd have to look at the code. My understanding is that the game just keeps track of um, like which indices you might be at or in between. Sometimes they don't count when going too low. Yeah, so one of the things to note, and I think this is pretty smart, um, every single track in the game, um, the start line is at 000, and the well, I guess yeah. So every track is at 000, and it always points in the forward direction. So right now, it says that, forward is this way, but anyway, disregard that. Right, like the track always kind of goes off in the one direction, and it's always at 000. So for suicide finish, you have to cross the finish line, which is to say you have to be, you have to be on the blue arrow side of this line. But at the same time, you also have to be above above 000, because otherwise it means that like maybe you've come falling down like this way. But here, and if I do this, right, it means that like if you come falling, you definitely have to be above the line, right? To cross the finish line, you have to be above it, so you can't like fall underneath. Then you also have to be on like this left side in this visualization, right? So there's stuff like that. So it's just like a couple simple checks, like is y greater than 0 or greater or equal to 0? And also, are you on the one side of that point, right? Like is your z value, I guess in this case it would be negative, but yeah. So I think it's really just that check. So it'd be actually interesting to know, and this could be something to, that can be, tested with the custom stages. Like if you do a suicide finish and you fall beneath the track, cross the finish line, and then there's like a scoop that puts you above y, like above 0 on the y-axis. If after that it would count. So maybe that's what you're talking about there. Yeah. So hard to say. It's a couple checks. I think there's more stuff to figure out about the checkpoints, but yeah. Yes. It's also going to help test the limitations of the game a lot too. Right? Like again, those like shift boost lines, or also just like if, right, like because here's one of the things too. If every triangle of a boost counts as like its own custom little collision for like boosting to happen, you could just do like you could almost think of it like a checkerboard pattern, or just like a narrow strip of those of like boost collision, and you could just make like a long strip that's just like that, so that you could like every frame you're hitting multiple polygons like per point on the vehicle. So you could do some really crazy stuff. It'd also be interesting to figure out too, like if you could stack up those collisions. Like what if you had like a slippery heel strip? Or what if you had a boost collision, but in the air or something like that. So it'll be interesting. But yeah, cool. All right, I think I'll leave it at that for today. Thank you for those of you who sat around and listened to me talk about code things and some of the, spreadsheets. Okay, cool. So my thought, my hope, I guess, that I'll do this like weekly, little updates. Yeah, so have a great day, everyone, or a great night, whatever time it is for you. And I'll be in the F0 Mods channel if anyone has questions. Cool. Yeah, no problem. Again, I figured it would make more sense to do this kind of stuff, rather than it kind of just being a shut-in or something like that. Alrighty. Cool. So take care, everyone.